In this video, we're going to talk about average rate of change. Average rate of change is just a fancy way of saying slope for a given interval on a graph. The reason we call it the average rate of change is because when the graph is a curve, it does not have a constant rate of change. It's variable across the entire function. So we have to decide which part of the graph we want to find the steepness for, and that part will be defined by an interval notation such as a compound sentence, or we may see it given in a notation that looks like this. We did the same thing for quadratic equations, so we'll do a similar strategy here. For this first example, the first x value given in our interval is -2. We're going to find the point on our graph that has an x-coordinate of -2, and that point is -2, 2. The second x value given in our interval is -1. So we'll find the x-coordinate of -1, and the y that goes with that is 0. So these 2 points lie on our graph, and our goal is to find the rate of change between those 2 points. For these, because they're given on the graph, I'm just going to count the rise over run. We can also use the slope formula, and we will use that in our upcoming examples on the next page. So here I'm going to go from left to right, and I'm going to count the rise, -2, and the run, +1. So my rate of change for this function over the given interval is -2 over 1, or simply put, -2. For my next example, the first x value given is 1. So I'll find the point on my graph that has an x-coordinate of 1, and that's 1, 3. The next coordinate given is a 2, and that's off of our graph. So we're going to change that and make that a 0. Which really, if this was written correctly, and if we didn't have to make this adjustment, it should be from 0 to 1. So we'll go to 0, where our x equals 0, our y coordinate is -1. Again, on this one, I'm just going to count because they're close together and it's a nice big graph that's easy to count on. 1, 2, 3, 4 over 1. So my rate of change for this function is 4 over 1, or 4. Now if we move on to the next couple of examples, here we're given an equation. And for the equation, we'll have to use the slope formula to substitute the coordinates of our points. Either that, or I suppose we could graph the function if we wanted to, but the rate of change equation is y2 minus y1 over x2 minus x1. So if we know the coordinates of 2 points on the function, we can use that equation, that slope formula, to find the average rate of change. So in our first example here, the function we're using is y equals 3 to the x. And the first x coordinate that we've been given is x equals 1. So I'm going to substitute 1 into the function, y equals 3 to the first power. That gives me, that gives me y equals 3. This tells me that the point 1, 3 is on the graph of my function in x, y order. Now I'll use my other x coordinate given, which is x equals 3. So y equals 3 to the third power. And again, I'm substituting for x into my function. 3 to the third power is 27. So the point 3, 27 is also on my graph. Those are pretty far apart from each other to have to graph and count the rise over run. So we'll use our slope formula and we'll subtract the y's on the numerator. Whoa, that's sparkly, but it's a little much. Let's try this. We'll subtract the y's on our numerator. So that'll be 27 minus 3, and we'll subtract the x's on the denominator. So that'll be 3 minus 1. And notice I subtracted in the same order. 27 minus 3, 3 minus 1. So 27 minus 3 is 24. 3 minus 1 is 2. So our slope is 12. For our next example, we'll repeat the same process. Our first x value given is negative 4. So for x equals negative 4, we'll have y equals 2 times 1/2 to the negative 4. Well, this is a bit tricky to evaluate. You can certainly do it by hand or you can do it with your calculator. I recommend, since we haven't done a lot of practicing with negative exponents, I recommend using your calculator and substituting it into your calculator. If you don't have a calculator, here's how you would follow the order of operations. You would have to apply the exponent first. The negative exponent flips the fraction, and it'll make 2 to the 4th go on the top. So 2 times 2 is 4, times 2 is 8, times 2 is 16, and that gives us 32. So the point negative 4, 32 is on our graph. Then our other point given is, or x-coordinate is 0. So y equals 2 times 1/2 to the 0. Anything to the 0 power equals 1, so that gives us 2 times 1, which is 2. That one was a little bit easier. Then we'll use our formula for rate of change. So that'll be 2 minus 32 on top. Again, we're doing the y's on the numerator. Y minus y, and then the x's on our denominator. So x minus x. So 0 minus negative 4. Be careful with your signs, that's double negative. So 2 minus 32 is negative 30. 0 plus 4 is 4. Negative 30 and 4 don't divide evenly, but we'll go ahead and simplify, dividing both the numerator and denominator by 2 to give us negative 15 halves.